All right, let's talk about one of the most fundamental pieces of the Kubernetes puzzle, the Kubernetes service. This is the thing, the network anchor that makes a totally dynamic, constantly shifting environment actually work. Let's get right into it.
So to really get why services are so crucial, let me just ask you this. What if you were trying to use an app, but its IP address, its basic location on the network, just changed every 10 seconds? How on earth would you ever connect to it? Sounds completely chaotic, right?
Well, surprise. In the world of Kubernetes, that's pretty much exactly what's happening all the time. Pods are designed to be temporary, what we call ephemeral. They get created, they get destroyed, they get moved around constantly. And every time a new pod spins up, bam, it gets a brand new IP address. We call this constant change IP churn.
And all that churn creates a huge issue, something we call the moving target problem. It's really the core challenge that makes trying to connect directly to pods a complete non-starter in a real Kubernetes cluster. I mean, think about it. Pods are volatile, but that's a good thing. It's what makes Kubernetes so resilient and self-healing. The problem is, if your front-end application tries to talk directly to a back-end pod using its IP, that connection is going to break the second that pod gets rescheduled or scaled. There's just no way for a client app to keep up with that constant flux. So, how in the world does Kubernetes fix this moving target problem? Well, it gives us a really elegant solution, a stable, logical front door for our applications. And that, right there, is the Kubernetes service. So what is it really? A service is this powerful networking abstraction. It gives you one single, unchanging virtual IP address that acts as a permanent entry point for a whole group of pods, and it doesn't matter how often those pods in the background are getting created or destroyed. It totally decouples the stable identity of your app from its ephemeral parts. Now, to make this idea really stick, let's use an analogy. The absolute best way to think about a service is to picture a corporate receptionist. So imagine this. A client calls the main corporate phone number and asks for the billing department. Now, the receptionist doesn't need to know every employee's direct line or where they're sitting today. They just look at their directory to see who's currently working in billing. Then, they just forward the call. The caller gets connected seamlessly, without ever knowing the details. Okay, let's map this back to Kubernetes. That stable corporate phone number, that's the service's virtual IP. And the receptionist's directory? How do they know who's in billing? Well, they're looking for employees wearing a billing badge. In Kubernetes, that badge is a label, and the directory is the label selector. The service is just constantly watching for any pods that have the right label and automatically sends traffic their way. So we have this kind of magic virtual IP, but how does it actually direct traffic? Who is the receptionist inside our cluster? Well, that brings us to a super important component called kubeproxy. You see, kubeproxy is this little agent that runs on every single node in your cluster. Its one job is to watch the Kubernetes API server for any changes to services and their pods. And when it sees a change, it literally rewrites the networking rules right inside the node's Linux kernel. It's what makes that virtual IP address real from a networking standpoint. And kubeproxy has actually gotten way faster and smarter over the years. It started out in this user space mode, which was pretty slow. Then came IP tables mode, which was a huge leap forward because it moved all the logic into the kernel. And now, for today's really massive clusters, we have IPVS mode, which is just built for pure performance at scale. And this table really shows you why. Using IP tables is kind of like searching for a name in a phone book by flipping through every single page. The more pages you have, the longer it takes. That's what we call ON complexity. But IPVS, that's like using the index at the back of the book. It takes you straight to the right page every time, no matter how huge the book gets. That's O of 1, or constant time. And for scalability, that's a total game changer.
Another massive scaling improvement was moving from endpoints to endpoint slices. The old way, if your service had, say, 1,000 pods, all 1,000 of those IPs were in one giant object. If you just added one more pod, that entire huge object had to be sent to every node in the cluster. Endpoint slices fixes this by chopping that list into smaller chunks, or slices. Now, if a pod changes, only its tiny little slice gets updated. It's way, way more efficient.
Okay, so we get the mechanics. Now let's talk about how you actually use these things in the real world. Because Kubernetes gives us a few different types of services, and you gotta pick the right tool for the job.
This is basically your cheat sheet.
ClusterIP is the default, and it's perfect for internal traffic between your microservices. NodePort exposes your app on a specific port on every single one of your nodes. Super useful for development. LoadBalancer is the go-to for production in the cloud. It'll automatically spin up a real cloud load balancer for you. An ExternalName is a clever DNS trick to make something outside your cluster, like a managed database, feel like it's a native part of Kubernetes.
Now let's talk about a really common headache. When you're using a NodePort or a load balancer, traffic might hit one node, then get bounced over to a pod running on a completely different node. To make sure the reply gets back correctly, Kubernetes does this thing called source-NAT or SNAT. But here's the problem: your application doesn't see the real user's IP anymore. It just sees the IP of the node that forwarded the traffic.
The fix for this is a setting called External Traffic Policy. By default, it's set to cluster, which gives you that nice even load balancing but hides the source IP. If you change it to local, you're telling Kubernetes, hey, only send traffic to pods that are running on the same node that got the request. This preserves the client's IP, but there's a trade-off. You might end up with uneven traffic if your pods aren't perfectly spread out.
And finally, there's this really interesting special case called a headless service. You set this up by literally putting ClusterIP none in your configuration. You're telling Kubernetes, don't give me a virtual IP and don't do any load balancing for me. So what's the point? Well, when you look up its DNS name, instead of one IP, you get back the IPs of all the individual pods. This is absolutely essential for stateful systems like databases, where each instance needs to find and talk directly to all of its peers.
Okay, services are powerful, but let's be real, they can be a pain to debug when things go wrong. So let's run through a couple of the most common problems you're going to hit.
Here are the big three. First, if your service has no endpoints, I'll bet you $1 it's a typo in your label selector. They have to match exactly, and yeah, they're case sensitive. Second, if you're getting connection refused, it means the traffic is getting to the pod, but the app inside is rejecting it. Double check that your service's target port matches the port your app is actually listening on. And third, the classic. It works with port forward, but not the service. Your app is probably only listening on localhost. It has to listen on 0000 to get traffic from anywhere else, including the service.
So to kind of wrap things up, this quote here really says it all perfectly. The service is the fundamental glue. It's what holds this entire dynamic, distributed system together and makes it usable.
At the end of the day, by creating this clean separation, this break between a stable network identity and the constantly changing pods behind it, services are what unlock the real magic of Kubernetes, the automatic scaling, the self-healing, the seamless updates. They are the absolute bedrock of cloud-native resilience.
And that leaves us with one final thought. With all the buzz around technologies like service meshes, which add even more advanced routing and security, what does the future hold? How is the role of this classic, fundamental building block, the Kubernetes service, going to evolve? It's a really interesting question to think about. Thanks for tuning in.